Hi, everybody. This is Anurag Tandon. You heard me at the keynote. If you saw that there, what an awesome keynote! And thanks Tim for the presentation about Motif. Let's talk about Bloom. Uh, as you can see in this whole track, it's all going to be about visualizations. So graphs are inherently visual. We have so many different options for you to look at your data in a visual way. No matter who you are and how and what your use case is. And here are some sample examples from a few that I pulled out of some blogs because every time I hear somebody talking about Neo4j and what they've done with graphs, there is invariably a visualization in there. So take a moment and see if you can identify any of these tools that were used to draw these visualizations. Drop them into the chat, and I will flip to the next slide, which shows you exactly which ones these are. So in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, so number one was browser. Number two is NeoViz. Browser is, of course, our Neo4j browser developer tool. NeoViz is an open source library that was built on top of Viz.js and is used to or has been used to draw visualizations of algorithms. Linkurious, one of our partners, their tool, and then of course Bloom. And let's talk about Bloom. Like you heard me talk about this at the keynote, so I'm not going to belabor it too much. But no matter who you are, developer, analyst, data scientist, managers, they're all have some needs for visualizations. And what Bloom tends to solve for is graph exploration in a visual way, very easy to get started, and essentially making people have the ability to prototype concepts faster, explore graphs visually, share information with their colleagues, and explore what they're seeing, so that everybody gets the value of the graph and the value of what you're trying to do. Bloom is really, really intuitive. And what I thought I would do is spend a little bit of time, because I'm sure that in the audience, we will have people who are familiar with Bloom or people who are completely new to Neo4j or to Bloom. And so I'm going to spend some time also demoing Bloom, and I'll try to focus a little bit on some of the new capabilities that we've added. Uh, but I'll also touch on some of the basics. So here we go. I am just going to go ahead and get started with Bloom. I am logging in to my database that I have running. And in this case, what we have is a yet to be released version of Bloom. It's actually coming out in this month, hopefully next week, if we can make it next week. And so what you're going to see is some brand new capability today. This is Bloom 1.7, a pre-release of it. Immediately what you're seeing here is I'm basically brought into the interface of Bloom. I am able to see what's in my data set. So I've not created anything yet. For those of you who are familiar with Bloom from before, one of the things that was a requirement for Bloom to work was a perspective. A perspective being a view or a logical view of the graph, and it has things like on top of the item label, which is a type of node that you have in the graph, what properties there are, what properties should be visible, what properties should be a caption, picking and choosing things like what colors do I want on my nodes, and what sizes should they have, and what icons should they have, and things of that nature, and some of the other things that we will take a look at throughout. And so what we've done in 1.7 is really eliminated the need for you to actually explicitly create a perspective. Bloom creates one for you right away, and then drops you into the scene where you can start just exploring your graph. Here we go. I have a graph now. So what I'm going to do is I'm going to actually pull in a perspective that I have from before, and I'm just going to load that one here. And immediately what you will see is like, this has not changed. This has not changed, but hey, we have some icons showing up now, and maybe some different colors showing up for these different categories. And there we have in the scene that I've pulled in categories, I can see these icons showing up for this particular scene. So let's take a look at what are the capabilities of Bloom. What can I do with this data? So for example, if I have electronics here, I just pulled up this this category of electronics, I can go ahead and start looking at, what is this electronics category connected to? So it's connected to items that belong to the electronics category. And in this particular data set, which is a retail, essentially transactional data set from an online UK retailer that we got from a paper. And then we've enhanced this data to have a bit more information about, let's say, if I pull in the USB office mirror ball, that I can see relationships like not only what transactions contain this particular item, but what also things like which customer bought this item, and then even things like similarity relationships where an item is connected to other items and some scoring based on that and so on. So this is the kind of data that this data set has. And if you're a developer and you're playing with visualizations, and oftentimes what the developer is really looking to do is making sure that the data is correct and the data is accurate, that the processes put into place to work with the data are working well. That's one use case. Of course, another use case is to explore the graph and see what the connections are, in the particular graph, for a variety of reasons. Like you might be answering a question about a certain relationship or a certain path and so on in the graph and so on. And so, just coming into this interface and exploring it like this, where I'm just going to go ahead and see what transactions contained this particular item, or what customer made this transaction and so on. So that's one way to go about and explore inside of Bloom. Really point and click, just some little typing in the search, and off you go. You don't have to do too much more than that, right? So it's very, very easy to get started, going back to like the agility and the speed of graphs. So given that, that's sort of one way of exploring. But how about we try a bit more of the search? So there was a USB office ball or something like that was the item that I found there, and I wanted to see what category this particular thing belonged to and which customers have bought this. So I might want to put it in a graph pattern. And what Bloom is showing you already here are all the list of categories and relationship types that are available. So these give a pretty good starting point for what you might want to put into this search box. So I can go in and say, oh, USB. And okay, I'm not finding anything. Why is that? Well, USB was uppercase, and so I need to turn on the case insensitive searching. So let me do that. And oh, there we go. Actually, it found it. So yeah, there are categories connected to the USB office mirror ball item. And as I put in these values, Bloom gives me these proactive suggestions, which is looking into the graph to see where these connections are. What are items connected to? Oh, they're connected to customers. They're connected to other items. They're connected to transactions and so on and so forth. So Bloom, basically gives these options, here. And if the search box is a little slow, maybe we can go full screen on it. And then we can go ahead and start seeing, the customers who have bought this particular item and the item belonging to a particular category. So this is the kind of searching that Bloom enables. There's a lot more to searching. There are many other ways of searching, starting with an item, putting in relationship types, actually querying for values of properties and so on. And then even more advanced things like search phrases, which we'll cover in a little bit. So that's how we go about doing the basics of Bloom. And you'll see these context menus show up if I'm right-clicking on the canvas, or if I'm right-clicking on a particular node and relationship and so on. So let me clear that, and let's start with a little bit deeper type of analysis. So I mentioned items existing in this data set. There are lots and lots of items right now. We've limited to about 1,000 nodes at a time. I can, of course, up that limit up to 10,000 if I wanted to, but I don't want to clutter my graph too much just yet. So I have 1,000 items, and if I'm exploring connections in this particular item, in this particular graph, I guess one way to do it is start, zooming in and saying, okay, what are these things over here? I can also, lay this out slightly differently, where I lay this out in a hierarchical layout. Well, that's kind of funny because no connections exist yet in my visualization. So hierarchy, like I'm not seeing really any hierarchy here. But what if I just start picking on a particular node and saying, all right, expand that, show me some of these similar relationships that this item is similar to. I'm actually going to pick this other one because it brings back pink colors. That goes really well with yellow. All right, so here, so we have this particular item, and that's connected to these other items on the top. In fact, I can kind of scroll in here and kind of look around in this mini map. So these items are similar to my happy stencil craft, which is also similar to some of these other items here. Okay. All right, I can do this. I can do this for some of these other things as well. And then I'm remembering that, hey, we had this ball item before, right? So what if I just go in and try to find balls here on this scene? And there are 8 of them. And what if I just go in and say dismiss everything else? I'm just focusing on those balls that are in my scene, and there are 9 of them. And I can also, do the same thing what I was just doing with these items. So I can start visualizing these relationships more in bulk rather than clicking on one thing at a time. I can do that, and I can continue to do that for, let's say, everything else that's here, and start seeing, what things these things are connected to. And as I'm doing that, you can see this visualization getting a bit unwieldy, right? Like there's a lot in the scene here. I can't really lay out this in a way that I can make a lot of sense of this thing. So hierarchical layouts are great for some things. So for example, if I wanted to traverse and see the path going from this node over here to here to here to here to here, which are great for like lineage cases and supply chain cases and journey cases like patient journey and so on. That's awesome. But for a visualization like this, where I have lots of items and similarities between them, if I want to find clusters, this is really hard for me to kind of see that. So we can go back to our other visualization, which is the force-directed visualization, and it's a physics-based layout where it looks for connections and basically creates gravity around nodes and so on, and magnetic forces to lay things out more in a more efficient, space efficient pattern. And so here we can start seeing some of these clusters. There's some connections in this particular area, more connections here. It's a larger cluster, and so on and so forth. So this is kind of another way of going about and looking at connections in your data. Okay, so we were looking at it from a developer's point of view. Now we can go back and look at it more from an analyst point of view. And I mentioned that there are many different ways of searching. So here's one thing that we can do in Bloom, which is to essentially code in some of these Cypher queries. Cypher is our query language with Neo4j. And a lot of times when you are looking for something that is very specific, a search might not give you what you're looking for if it's particularly a complex type of query. And Bloom does offer you that escape valve of, okay, I can't really express this in search very well, so I'm going to just put in a Cypher query because I know Cypher, or somebody knows Cypher who can tell me what this query should be, or they have put it in for me, and I can do that. And then I can essentially use this query with more of a human readable or human expressible point of view, which is top items. So that's what I'm looking for, top items. So maybe I'm looking for top 10 items, and then I'm looking for top 10 items since a particular date. And this is one way of essentially running that Cypher query, which was a bit more complex than what I could write, and then also have it be parameterized. so that today I'm looking for top 10 items, but tomorrow I might be looking for top 5 or top 20. And I might be looking for different kinds of dates. And so for an analyst who does the same type of analysis, but does it with different points of view or different entry points, or maybe you're analyzing transactions, but different transactions on different days, or you're analyzing a customer or a bank account, or whatever the case might be, a patient, a drug, or whatever the case might be. You have the similar analysis in mind, and the process is similar, but the parameters or the values that you use on a daily basis might be different. And for something like that, these search phrases are awesome. So we could do the same kind of thing here, where I can pick or narrow down on one of these nodes. I'm liking this jumbo bag red retro spot node here, and I'm going to look for same thing, similar relationships to this particular item, and similar items related to this item. And then I can start seeing maybe, I think it had a few other items. Let's see. Yeah, so there are more relationships here, and I can kind of see what's going on with this item and its neighbors, right? So I can essentially go in and then try to find out, are these items belonging to the same community? Because we've done some community detection as well in this particular data set. So I have this thing called Louvain community, which is a property on each of my nodes. And what I'm doing here is, by just going into item and going into this rule-based area, I can set up rules for styling. So I can set up something like Louvain community and show me colors of these items based on the unique values of Louvain community. And this is an ID field that my algorithm kind of coded into my visualization. So I can see that here. And as you can see, there are lots of colors on the scene, right? And why might that be? Like, these two look very similar. So are they the same community? This was 7899. This is 4519. Why is that? Like, this is another color that is quite similar, but not the same. And I can look at a different community here. So it looks like the community values, even though the colors are looking similar, the community values are very, very different between these. So maybe there's something going on. Like, visually, the thing is telling me that these things are very similar in the same community, but they're actually not. And so at this point, the analyst might wonder, is the algorithm running appropriately? Was it done in the correct fashion? Or is there something else in this data that is worth considering that is not being taken into account? So this is the kind of thing that offers a chance for collaboration between different people. And you could say, all right, let me just export this data out. I can export it as a CSV. I can hand it to my data scientist to say, hey, this is what I'm seeing. I'm not going to give you the entire graph. You have access to it. You can go play with it yourself. But this is what I was seeing for this particular red retro spot bag. And could you please tell me what's going on here? So now let's take another point of view, which is the actual data scientist point of view. And I'm actually going to get rid of this rule because I'm going to need other rules later. And so I'm going to now come in with the point of view of a data scientist who is putting together a recommendation algorithm. And they're trying to figure out steps in the recommendation algorithm for, how do I go about recommending items similar to other items, right? So let's first of all look for customers that have bought a particular item, space owl. And let's look for customers who have bought not just this one, because that's not the only item I want to base my recommendations on, but maybe an intersection of two items, right? So I've picked up these two items. They might be belonging to the same category or a different category. And I'm essentially saying, all right, this customer has bought these two items. I want to recommend to this customer or customers that look like or are similar to this customer other recommended items. And so if I wanted to do that, first of all, similar to what we were doing so far, I can pull up the items that are again similar to these two items, and I'm actually going to go both ways here as well. And that essentially gives us this view where you have this item, which is the space owl right there, has more similar items. This has fewer similar items. And I can start seeing a bit more detail about the similarity relationship. So I can go into the score property and say, let me apply a rule based on scores. And I'll size things this way so that I can see where similarities are stronger. And we can see Space Owl has stronger similarities. This one doesn't have as strong similarities. So maybe I don't really need to look at this. So I select these guys and I dismiss those. I focus on just these items. I can also say, for these items, show me, are they belonging to the same category or are they belonging to different categories? And here I can start seeing, there are category relationships to these items. Maybe here a hierarchical layout can help me understand better. And maybe I can go into presentation mode. And here I can see this in better detail. And then what I can do is if I bring this back and say, all right, not only am I seeing the strength in terms of the relationships, but what about the items themselves? I have a property called PageRank. The PageRank tells me influence or the influence of an item in the network overall. I can apply a size based on PageRank, and I can take a look at what's going on here. So I have items that are stronger in their strength, but lower in PageRank because they're not sized as big. But I have these other items that are actually belong to the same category that all have both have bigger sizes. In fact, this other one over here is also bigger size. So I can take a look at this particular category. Oh, it's home decor that has some items that are stronger in their influence in my network. So maybe that's a good category to kind of look at, right? And then the final step that I might do here is actually coming back out of presentation mode and applying some filters. So then I can take this data and say, let me go to similar relationships, score greater than 0.4. Like these are the items that I really care about. And then continue to add a few other things here. Maybe I don't care about categories anymore. Maybe I want to also limit my items and then say only PageRank above a certain value. Here we go. And then that narrows down the field for me dramatically, right? And then I can say, all right, dismiss these guys that I filtered, and let me just focus on these items over here. And then they form the recommendation for what it is that I'm going to show. So this whole sequence, I'm doing it visually. It actually is done by machine, but this is a way for me to kind of walk through what the machine is doing and explain it to other people that this is exactly what the recommendation algorithm does. So here were some of the few cases of what Bloom helps with. And I'll quickly just kind of run through a couple of details that I didn't cover. So perspectives, didn't really talk about it too much, other than showing you the default perspective. Let's just kind of generate it for you by Bloom, and then the thing that you can generate and tweak yourself. But you can create these different views for different purposes, different people, different groups, different roles, different problems that you're trying to solve. Search in Bloom, I mentioned there are quite many different ways of searching in Bloom, and there are many different suggestion types that you get. Please look at our documentation for all of the details there. Bloom offers a couple different layouts, and we continue to look at expanding this portfolio of layouts as well. Let us know which ones you would like. And then integration, something I didn't really talk about much, which was about coming from another application, linking in some context into Bloom, and then starting your entry point of your visualization from there, right? Super powerful. Bloom has a couple different application modes available to it. There's basic access, which is without the server component that we have, that essentially gives you access to local databases and running visualizations on top, like running Bloom inside of Neo4j Desktop. And I'll talk about that in a second. But essentially, It gives you all the visualization power on local databases and stores things locally. These perspectives are stored locally. But then if you really want to have collaboration and sharing with other people and accessing servers for Neo4j, you need that full access. You need that Bloom plugin. Several of our customers are, of course, using Bloom. The list keeps on increasing day by day. Lots of different use cases this is used for. And then the final thing I'm going to kind of leave you with is, if you want to try out these basic and full sort of variations of Bloom, here are 3 different ways that you can try Bloom. Neo4j Sandbox has the full functionality, timed to 3 to 10 days. Neo4j Desktop, you can have the basic stuff available forever. Neo4j Aura, if you have an instance there in Aura, including the Neo4j Aura Free that was announced today, you have access to Bloom as an extended beta there, and give it a try. So that's all for the presentation, and I hope you have some questions for us, and we'll take that in the panel discussion.